Hi there, it's David here, and I am pumped to be making this first breakdown of the Liquid Alphabet series. Obviously, this is going to be based on the A simulation, so I mean, it's not the prettiest thing to look at, but the core concept here is, of course, viscosity fluid. Viscosity meaning the attribute of the fluid that describes its resistance to flow. So the higher the viscosity, the more kind of goopy or chunky it can become and kind of create these build-ups and details. So aside from this, pretty half-assed and quickly output. And then we can also take inspiration from this sim with the Buddha statue that I made a while back. The model comes from the Stanford 3D scan library, so I can't take any credit for that. But I think the sim turned out a bit better, at least than the A simulation. So the main thing I wanted to look at here was, the pattern that the emitter is going back and forth. And so anytime you can think of pouring ketchup on a hot dog or chocolate sauce on an ice cream sundae, that's really what we're going for here. So even if you can keyframe that, I think it becomes a bit tedious pretty fast. And it's nice to just, with a few parameters, being able to control how far the emitter sways back and forth and how fast it goes. So we're going to look at that with trigonometric expressions inside of Realflow. And last but not least, of course, the latest one that I've been teasing. I'm going to show you how to take the existing simulation and filter out every nth particle so that you can render those as bubbles within the mesh, which gives a very nice appearance when it comes to building the render. So without further ado, the first objective here is, of course, looking at the viscosity properties and how to deal with that. And this is very basic stuff. If you haven't played with it before, it can be a bit daunting, but if you feel like you totally have this covered down, I would love for you to look at the chapter markers below in the description, and you can jump ahead to trig expressions if you want, or to bubbles inside Realflow. I thought we'd do the bubbles with the RF graphs, so that might not be for everyone. Okay, so here I am in Realflow, and I'm going to create a new project, and I have put in my folder in my project name. But remember I said in the crash course I usually pick the empty project, but this time basic viscous seems to be pretty much what we want. So we could actually go with this one and create the project and kind of see what the folks at Next Limit has set up for us. And then we can kind of start to pick this apart. I just want to make sure that my command line is off for now. And I'm just going to hit sim. And then we can start to pick this apart and figure out what it is that they did to achieve this. I want to say though, viscosity has always been around inside of Realflow liquids, but traditionally it was a real pain to create visco simulations. Back when we only had the standard particles, we could set the emitter to be viscous, but you would have to super crank the substeps to up in the hundreds or thousands in order to get viscosity. So it was really a pain. And then they introduced viscosity in hybrido. So you could, with any type of hybrido sim, you could create an open container, and you could do, pretty much what we're doing here now. But hybrido is supposed to be for large simulations, and it's maybe not the most effective, even though you can get away with less substeps. Honestly, it was when they introduced viscosity in Diverso is when things really started taking off, as far as I'm concerned. So we can see that the simulation is really it's piling up on itself. It's giving us those details that we like. We can, from the get-go, we can do a quick mesh here, just so that we see what we're getting. I mean, it's not bad, and we probably want to work with the mesh, and we probably want to work with the particle settings. But this is a pretty good start. So let's try to figure out what they did here. All right. So the main thing that stands out, if we take a look in the Diverso domain in the scene, is that they have set the particles to type viscous. And by default, the domain is set to liquid PDB, but if we set it to SPH, we can also get viscosity. The difference here is that the viscosity goes above 1, or honestly, you can set it to above 1 with viscous as well, but it doesn't really take it into account. If we look at the help, it says that viscosity ranges between 0 and 1 and can be animated. And to get a more rigid behavior, increase the substeps and iterations. So the result that we saw previously was not, you know, toothpaste or a thick cream or something like that. So if we wanted an even more rigid result, we could turn up the substeps. And as we have seen previously in the crash course, we'll find those in the options and diverso. We have the specific substeps for that. And we'll do a side-by-side real quick and take a look at the different results. So the main difference is that using SPH particles, you have viscosity above 1, really an arbitrary value that goes as high as you want it. And you can go online and find, you know, physics tables, what is the proper viscosity for water, chocolate sauce, honey, tar, whatever. But to me, that seems a little arbitrary, actually, because that assumes that your scene is real world in terms of scale and in terms of physical attributes. And in the end, all I really care about is the way the fluid looks compared to my reference. So honestly, it's a personal preference. I would go with just using the viscous type solver and setting viscosity between 0 and 1. And then if you want even more thicker behavior, then play with the substeps. So it's really up to you. But for the rest of the demo, I'm going to use this approach. Furthermore, they have a drag force. It's set to 0.1, which is the default. They have a gravity. And this is something easily overlooked. It's actually just set to 1, whereas the default gravity is 9.8. So honestly, they just want it to be flowing down and collapsing on itself, but they don't want too strong a gravity because that's just going to flatten out the fluid. So that's always going to be a bit of like balancing act between the gravity, the speed of the emitter, and you know, the substeps, the viscosity. So it all comes into play. And honestly, the only thing that really matters is you get a nice result that lands and builds the way that you want it to. And then afterwards, you can play with, you know, remapping the particles here inside of Realflow, or you can remap the speed of the mesh inside of your renderer, or you can, you know, set a high FPS value when you're simming and you can render every 4th frame or something like that to get a faster appearance, or just render and then speed up the play blast or the render afterwards. That's actually what I did for the A sim. I rendered the entire sequence and I thought this is way too slow to look at, and I speeded it up a bit. Obviously that's a waste of time, but you know, what I'm trying to get at is don't be too concerned about having everything real world. Be more concerned about the appearance of your sim, really. So now that we've seen this, let's just build this from scratch and do a bit of comparison with minimax substeps. So I'm just gonna delete everything just so that we kind of ingrain what they actually did here. So they set a strength of gravity of 1, and they set a drag force, and they set a diverso. If we do the emitter first, we're going to get the domain for free, which is going to save us the work of connecting those up. I'm going to delete the hub, connect up the gravity and drag force, and then they changed the type to viscous, and they have the viscosity at 1. And let's just rename this for now. I'll just call it Visco Default. And we can have that set to emitter 1. Next is collision plane, obviously. I'm just using the number of keys to position everything. So looking at first, you know, the 1 key, looking at top, the 2 key, looking at front, and then if you need to, I have everything scaled proportionally here, but if you need to, you can use 3 to look at the side. So that's what I have in terms of the 3D scene. I'm just gonna hit simulate now without command line, so we see the results instantly. And should of course connect the collider. So we can see the liquid piling up, and that looks so far so good. It's really thick, so the fact that the emitter is at a pretty low height means that the particles build up pretty quick, and then the particles have not been, you know, they haven't fallen out of the way, so that new particles are being emitted, and they end up on top, and we get this kind of mushroom shape. That could be counteracted by, well, either you create a faster emitter, higher gravity, or you just move the emitter around, which is what I was getting at with the Buddha. So let's see how we can set this up. First of all, I think I want a bit higher radius. I don't want at this stage to simulate at high resolution. We don't need to do that yet. So I'm just going to change the display type on the Diverso solver to a sphere, and then we can set a size that gives us more coherent appearance. Show a radius of Mr. Bond right there. And for now, I think I'll just leave it higher up and then maybe not do as many frames. So as soon as, you know, it starts to pack, then that pressure is going to build up through the solver, and you see that it's widening up here, and that means that they're now starting to collapse onto each other. I want to create a different shape of the emitter, and let's look at, you know, animating this slightly so that we can avoid the piling up for a bit. And we don't need to be running, you know, hundreds and hundreds of frames to see the difference. So let's just, I think I'll use the X value, and at frame 0 we'll have it over here. Let's look at the top view. And then, I don't know, 2 seconds, is that too fast? Let's try and have it over there. So now we've set 2 keyframes, just clicking that little circle. And you can go to open curves, either straight on the node, or you can click it in here on the attribute, edit curve, and that takes you to kind of a graph editor, and you can see what's going on here. We don't really need to be getting too specific with the graph editor right now, but just suffice to say that it's a pretty capable graph editor, similar to whatever you're used to from your 3D app or After Effects, something like that. You can both change tangents, edit the curves, and you can also do expressions, which is what we're going to look at later in this tutorial. Yeah, so let's just do one back and forth, or not even back and forth, just forth, and see how that looks. I think it should go slower. So let's go to edit the curve. And you can either, you know, a bunch of ways to do this, but I just go into the curve editor, select that keyframe, and I want it 50% slower, so I put that to frame 75. This is the frame and this is the value. And let's maybe go to 150 and put it back. I want to keyframe just the X so that we have the liberty of duplicating this later and move the new one in Z so that we can have several fluids alongside each other. And as usual, I'm doing that finger waltz with Control A and then space to confirm to reset the sim, and then A again to start the sim. So now we don't have that building up anymore. And I can see now that we need to add another daemon, which I actually overlooked in the crash course. So it's nice that we get the opportunity to talk about this now. Whatever fluid escapes the scene, we want to get rid of that. Obviously, if we were exporting cameras from our 3D app, we would know exactly what we're looking at. But we can assume that we want to work in this kind of crop, and I don't want to be concerned about particles falling down into infinity, taking up system resources really. So the daemon is on the far left called K volume, and as soon as you create that, any particle outside of this little volume here is going to be killed. And we can either fit this ourselves, or we can start by clicking fit to object or fit to scene. So if you click fit to object, you get a list to select an object. In this case, I want to fit it to the entire scene. I think that seems reasonable. Like, I want it to be able to flow over the edge, but then as soon as it starts falling down, I want it to be killed off. Yeah, so let's keep going. And also, I think maybe we should have actually had a faster emitter so that we see it more like piling up on top of itself. We could maybe even do shorter passes. It doesn't need to travel as far. So let's set that up. So open the curves again. And just frame it. You can also click this arrow with the kind of like scaling indicator. So it lets you scale the entire selection. So I'm going to scale by 0.5 in X, which is time. And I'm also going to scale by 0.5 in Y, which is going to be the value. So you see now it shouldn't move significantly faster, even though we shortened the time for it. But it should, if we look at the emitter, just select the emitter, reset the timeline. We see now that we're doing a pass within this area. And I'm just going to grab everything and Command C. Can we paste keys here? Paste, combined. Obviously cannot. Copy selected keys. Paste after timeline. Nope. Okay. Paste on current frame. Yeah. Cool. I think we got double there because I wasn't on the exact same keyframe, so I just deleted that duplicate. So now we have 2 passes over 150 frames. And I think this will do it really. But let's verify. And to be honest, it's just ridiculous how fast this is to work with, even now in the GUI. And I'm not even enabling CUDA acceleration or anything like that. This is so fast. When I think back to the days of doing viscosity with the standard particles, the substeps were so high and it always became unstable, and it would kind of do this little pop because particles ended up on top of each other because you didn't have enough substeps, and it would pop, and then you knew that, okay, I have to start over now. You have to crank up the substeps even more into the thousands, and you would just wait. And now here we are just looking at 150 frames in a matter of seconds. What I want to do though is I want to go into the options and make it go even faster, because I realized I'm not even using the CUDA GPU, and that's actually going to make a huge difference. In some cases, you get speed gains of, I don't know, 40, 50, maybe even, I don't know the number, so I shouldn't be guessing. But I'm going to pick one of my 1080 Ti's, and then I'm going to hit OK. And let's see, the emitter could possibly be a bit bigger. And let's just resum. This is nice. Now we have like a nice folding over itself, and I want it to stop emitting at this stage. So by frame 150, I don't want any speed anymore. So I will set, let's not do it just from one frame to the other to get a cutoff. Let's have it ramp down and see what that looks like. So I'll actually do it over maybe not 20, but 15 frames. So I'll go 135, set a keyframe at the current speed, and 150, set a keyframe at 0. Come on. Here we go. Let's sim again. And this is nice. So you can see that it's really slowly kind of folding over on top of itself. And if we create ourselves a bit of a mesh, we can take a look at the result. And a bit more fidelity. I'm not even going to tweak it, but you can see that if we lower the polygon size, we're going to see all these creases, which looks really nice. And let's duplicate the domain and get rid of the connection to the emitter, and that's actually, I'm just going to leave the name for now. Duplicate the emitter. I'm just to Control D, and I connect the new emitter to the new liquid, and I can use Z to offset it. And this one can have a viscosity of, let's say, let's do 4 different ones. So let's try 0.75, and then another emitter, and viscosity of 0.5. Take the new emitter and chug it out there. And one final fluid with a viscosity of 0.25, and a new emitter, and delete the connection to the recent copy, and put that emitter here. So just need to scale out the collision plane a bit. We can anticipate that the last few, they're gonna run out a bit. They're gonna spread out into a bit of a puddle. I'm also adjusting the shape of my kill volume. They're gonna spread out into a puddle and kind of interfere with each other. I haven't connected them to influence each other, so they're not gonna collide actually. Let's not waste some time on that right now. We can turn them on and off if we need to, but what we do need to be aware of is like friction on the collider object, just to try and counteract that a little bit. I'll just set the friction to 1 to try and counteract it as much as possible. So let's see what difference we get. We don't see any difference yet. They're just as much surface tension. They're falling in the same speed, obviously. But I think it's when it starts to pile up on itself is when we're going to start to see a difference. So you can really just take a look at the height. It's stair-stepping down. The lower the viscosity, the more it kind of like spreads out. And I think like the friction is holding them in place a lot. But if I were to mesh this now, we would probably see that the details in the fold there are preserved a lot better on the viscosity. This is all just melting together into a big lump. So we can see like that's kind of the way viscosity works. We're not going to spend too much time on this now. I want you to explore yourselves. But what I do want to do, however, I want to explore how the rigidity changes when we change the substeps. So let's do that now. We have 4 different fluids set up. So the first one is going to be viscosity at default. We're going to set them all back to 1. Yes, you can do that. Select multiple objects and change an attribute if they're of the same type at least. And I'm going to turn off simulation for everyone except the first one. And we already have this simmed, honestly, and it's full viscosity. So we don't need to sim it again. This is the default. I'll click the rocket to set it to yellow, which means it's cached. So we're going to see it in the viewport, but it's not going to be simulated. Let's enable the second one, and let's check the sub steps here. Let's do 10 and 20 and 20 iterations. So I'll just name it accordingly, 20 substeps and 20 iterations. And then, did I commit to that? Yes, I did. And then I will sim again. So this one isn't even being calculated, so I can turn it off. I turned off the wrong one, obviously. But if we take a look, you see that the 2021 compared to the default of 10 and 10 is preserving the shape a lot more. It's a lot more rigid, if you will. So let's continue the experiment. Let's set it to, let's just, for sake of simplicity, let's just double. So 4040. I'm going to cache the 2021 and I'm going to enable the 4041. And of course, it doesn't suffice with just changing the name. We also have to change the parameter 40 and 40. And I'm going to use the command line now. And now that this is actually simulating, I can set it to cache and we can play it back to see the result. I think I'm getting a bit confused here, so I want to change the colors as well. Default is going to be purple, pink, and the 2020, I'm just going to change the color to a bluish thing. And 4040, let's go green. Oh, this RGB is really frustrating, confusing sometimes. And that should do it for that one. And the last one, we can set it even before simming it. Let's set it to orange. Orange. There we go. So the 4041 is the green one. And it should be preserving its shape a lot more. And we can see that it really does. It's gravity is really struggling to force it down there in the end. So this is starting to look a lot like, you know, a very thick, pasty type of substance, which is pretty cool. And I'm simulating a lot of frames here. I really don't need to have 800 frames, which is the preset for this scene. I think I'll be happy with 300. And we have that one cached now, so the last one is going to be, well, let's continue with our principle of doubling. I think this is going to be pretty extreme. I think possibly we could have as much buildup that it will actually start to fold up on itself even before escaping the emitter, but let's see. It'd be fun if we could get a kind of extreme result. We have about 100 frames now, and we've already loaded the cache up to this point, so we should be starting to see those. And not too much of an issue there with getting it out. You can see the last few frames, how much it resists kind of buckling down. That's pretty cool. Let's finally just create a mesh for all of them. We can use the same mesh. We have the same resolution after all. And insert all particle sources. It's gonna do us fine in this case. Let's go with default settings first. And turn them off. And not too pretty. Let's lower the polygon size to, I assume we're gonna end up something like 0.25. Nope. Oh yeah, that works actually. I accidentally, just out of habit, started a sim. Well, that's fine. It's gonna start meshing now in a sequence. But I see that probably want to change a few more things. Let's go close out all the command lines. Let's look here in the end somewhere. This is probably when you want to use interactive meshing. So I'm going to go set it to bounded and just focus on one of these for now. I don't even need the whole thing. I can just do kind of half if I want to. Pull it up. There we go. And then I'm going to use Mesh Interactive. And we can see that the polygon size is starting to be satisfactory, but I think the radius needs to be tweaked a bit. Well, let's see. Shave off even a bit more polygons. Yeah. So we're starting to be really close to, well, obviously it's a lower sim, first of all, but I think we need to be even higher in terms of radius, because it's, you know, when you have such a lower sim and you have a low polygon size, then it's going to faithfully render the space in the mesh between the particles, and you kind of want to fatten up the radius a bit to get it to get them to bridge together again. So I'm going to play a bit with those. Obviously I could be starting to raise the resolution a bit, but I don't really think we need to spend that much time on this. So just fatten them up a bit, and obviously we need to make that settings for each and every one of these children of the mesh. I'm going to stay on 0.125, and then I'm going to add some filtering. I think in this case all we really need to do is to smooth it a bit, a couple of times, maybe 4. This will do it for now. I mean, in the real world, if I wanted to be really happy with this, I would easily have raised the resolution in several passes, and in order to get a more like a smooth result. But this is for, you know, it's detailed, at least. It's showing exactly what we have in the particle sim. So I'm going to turn off interactive and then turn off bounded. Never do it the other way around, because then the interactive is going to trigger going from the bounded mesh to the whole mesh, and that usually results in a crash. And now we cooked up, and now we can easily see the result, right? So the higher ones are pretty similar, actually. And you could take this even further on your own. Like, try to go up into the hundreds, and possibly you're just going to see a big cake that hardly deforms at all when it lands. But really, this is all that you have to play with. The counteraction between the speed of the emitter, the gravity, the viscosity setting, and the substeps. That's all there really is. And honestly, I'm a bit jealous if you are just getting into liquid sims and are looking into doing your first viscosity sim. You have it all laid out for you, all the goodies. It's such a fun tool to work with, and it's quite a lot easier these days than it was before. But that's the way it should be, right? It should be a tool that is available for us to play with creatively. And it wasn't, honestly, it wasn't that creative back in the day, like when I tried first time. Honestly, I think the first time I tried Viscosity Sims, I just gave it up because I wasn't patient enough. It was around the time when they started introducing viscosity in Hybrido. I think I started playing with it. There were a few brave souls back then who created like those first sims of, really thick taffy, kind of winding down on a candy bar or something. But those were real heroes. It was a real pain back then. So I think I'm happy for now. We have looked at different viscosity settings with different substeps, and let's move on to playing with emitter and trigonometric expressions. So I think just for sake of practice, first of all, let's consider which one we want to keep in this case. I don't really, just for sake of time, I will stay low in the substeps, and then let's do something like 20, 20. And I'm gonna just stick with one sim for now. We don't need to be creating all of those at the same time. And let's, for sake of practice, just create a scenario a bit more similar to the ABC sim that I did. So I'll just use geometry and text, and I'll put an A in here, and let's find some kind of a, like a bold font or a grotesque or sans serif. I tend to recall I used something like Franklin Gothic. Maybe we could use. You can push up the font size, or you can just instead scale it afterwards. So we have the text object there. I'm just gonna rotate it and then scale it. So we have it kind of laid out similar to what I had before. Not the most exciting composition in the world, right? But who cares? Let's do this. I don't know. Let's do a red A. And let's say then that we want to have our emitter flow from left to right, but also have it go in zigzag across here. And you saw it was fairly easy to be setting those keyframes that I did, but honestly, I don't want to be copying and pasting keyframes over and over. That's just going to be frustrating. So instead, we're going to use trigonometric expressions. And honestly, even before we start to simulate, let's just play with this. And I'm just going to reset everything and put a sphere over here and look at what we can do with trig. So I'm just going to go to the position. And this time, instead of setting keyframes, I'm just going to go to edit curve. And if we wanted to create the same kind of behavior that we had with the emitter going back and forth in X, we had it going to the edge of the platform and then back. I'm just going to go to sphere, X, and then down here in the expression, I can hit insert, and I can toggle between different functions inside Realflow, such as unary functions, binary functions, ternary functions. You can fetch attributes from other objects, and you can do if-else and everything like that. I'm just going to hit the sign one. I'm not by any means the right person to give you the lecture about what sine really is. What I do know is, if you know your trig, it's a function, a mathematical function that describes wave patterns. And so if we look at the formula for sine, this is the function, and it expects a value, obviously. And that value is typically time, which is the variable t in Realflow. And then you can put a magnitude in front if you want to. I'll show you that in a bit. And then if you need to kind of shift the entire timing, you can add or subtract to time. For offset basically, so you can kind of to shift it one way or the other. And so this is really how we kind of control it. So let's take a look at that in the same order. So if we just push sine without giving it anything, it's just a straight constant of 0, obviously, because no value. And if we give it values, it changes, but we don't really get anything other than a constant value. Obviously, we have to give it a varying number, a variable, in this case t. And as soon as I give it t, you can see that it undulates over, you know, like 100 something frames. We get a full kind of rotation or full cycle, and we get a value between 1 and -1. And that's why we need to use a multiplier before the whole equation, because in our case, if we look at it from the oops, I kind of typed in there instead of change the view, we can see here that it's roughly like 1-2 units maybe that we want to travel. So let's double it. And inside of Realflow, you can actually be pretty brief with this equation. You can just type like 2 sine t plus 1, for example. While if we were in Maya right now, for example, we would have to type 2 times sine, and then the variable in Maya is not t, it's time. And then so it's a little, you know, it's a little easier actually here in Realflow. So you can give it 2 times sine, it put in that multiplier for me, and then time. And then if I need time to pass faster, I can multiply it, or just press like 2t. That is twice as fast, 4 times as fast. If we want to make it go slower, we can divide it, or we can multiply it by fractional value. So I want it to go slightly faster, so I'll go 2t. And let's say maybe that I want it to be, just speaking of that offset that I was talking about, let's go to the perspective. And maybe we want it to start like at frame 0, we want to be at the upper end here. If we scroll through the timeline, we see that the upper end is when it's at the lowest point of the graph. So we want to shift the value until the bottom, the valley of this sine wave is at frame 0 here. So I'll just go in and try something. -1, 1.2. Whoops, kind of put that in the wrong place. Just reach that, and 1.2 maybe. 1.5 maybe. Yeah. So now we hit the value there. And if we go to frame 0, we can see that we're at the top here. That's really just like, if you really want to like manipulate it. And then to take things further, if we give the same formula, I mean, obviously we could now be just happy with this and then set a keyframe in the Z axis and kind of have it run along like that, where we get this. That's pretty much what I did with the A. I just let it run slowly over the whole range, and while it was going back and forth rapidly. But before we do that, let's explore some more. What if we put a trigonometric function in the Z channel as well? So if we put the same thing, I just copy and pasted, what do you think happens? Let's have a look. That gives a kind of like a diagonal pattern. But if we were to offset this by, you know, like half of a cycle, I think we could get a pretty interesting result. And we don't have to figure out the offset for that. We can just use another function called cosine, because a cosine is kind of like a sine wave, just with the offset of half a frequency. And if we do that, all of a sudden we have this running in a perfect circle. And you might say, well, I could have parented to a null and rotated that null. And yeah, you could. But it's really flexible now to like, we could be tying up the magnitude value to, let's say we bring in a null and we tie up the magnitude value to the position of that null, for example. And then we all of a sudden have a controller here. So we can kind of create a spiral pattern or something like that. So this is pretty interesting, I have to say. Speaking of that, let's just do that, by the way. Let's just go to geometry and create a null. A null isn't going to do anything for us aside from just being a placeholder in the scene, something to parent stuff to, something to link stuff to. So instead of this number 2, I'm going to create a dvar. And the dvar is, you know, it's just a variable, pretty much. I don't really know if you can actually create custom attributes inside of Realflow. If you do know, let me know. So typically what I do, it's not very often I need to set these things up as we need to do like in Maya pretty frequently. So instead, I just create a null and, you know, plug it to the position, for example. So let's say we plug the x position. And I'm going to put, just to keep things neat, I'm putting it in the front and I'm replacing the 2 with null position.x. There we have that. And let's go to x and do the same thing there. So you'll see that the sphere is now in the center. So I'm kind of like, you can actually see the graph changing in there when I move the position of the null. Or you could a while ago at least. So let's play with this and see, like, what if we keyframe like from 2 on the null x, and we put it at, let's say, frame 100, and we put it at 0. And let's see what that gives. Should probably remember to set a keyframe. And 0. So you see what happened? It kind of spiraled inwards. How cool is that? And I'm just gonna have a way faster sine, I think, and cosine, so I'll put 6t instead. So now we kind of like create this pattern where it spirals inwards. You can imagine, like, if we were pouring now, we would create, you know, like kind of as if you were spritzing the cake and you wanted to make a nice little spirally, twirly thing. Something like that. But honestly, I'm getting I'm getting way more elaborate than I usually do. Usually, I'm just gonna delete this. Usually what I do is I just use this to go back and forth, and sometimes, you know, up and down in speed on the emitter or something like that. If you have an emitter that's kind of like shooting out, then I might put a sine expression or something on the emitter speed. And you can also do something like, I'm actually just going to clean up this a bit now. You can also do something like put in a random or a noise, for example. It's important kind of like what you have selected when you go into that list, because otherwise you might put your entire thing. Well, that didn't help at all. It just put my entire like sequence into parentheses. So now I have I cleaned that up. So I have R&D parenthesis 1. So I'm just adding this first of all to the entire equation, and you can see that so it follows the sine wave, but it it has a randomness applied to it as well, and a way too big randomness, to be honest. I want like somewhere between 0 and 0.1 is now going to be returned, and it's going to be a new random value at every frame. This might be more suited for something else, but you know, if you wanted to kind of bring in some shakiness to it. And obviously we're not going to use the sphere, we're going to use the emitter. So I'm just going to copy this and delete my sphere and go to my Diverso emitter. And we currently have keyframes on X. I'm going to get rid of those and put in the sine expression instead. And then I'm going to keyframe in Z. So starting at a value of 3, keyframe that and go to frame 250 maybe, and take it way over here. Use the orthographic views to be precise. There we go. I think we can afford to be a little slower in the sine wave. And also I want to do something else. I want to slant it kind of as we go as well. So let's figure out like the Y rotation. If we give it something like a 15-degree sine, just a pretty slow one. So I'm gonna go to Y and like 15 sine and like 2t. Let's try that. So you imagine like the pastry chef is twisting his wrist as he's spritzing the cake, kind of thing. And as soon as I start the sim, it's always like you start the sim and then you realize, oh, I should have done this. Should of course connect our text as a collider. And I want to have a bit of friction on that. And I'm starting to think like maybe we don't really need like full viscosity on this. Let's try 0.5. We want it to spread out a little bit at least, and maybe take the gravity up slightly. So just kill the command line sim and go again. So I'm leaving the mesh in there and we can look straight at the mesh, kind of like the first thing we do. And I've already gotten like 20 frames. So there we have it. It's kind of stair-stepping a bit. We could also be wiggling it in trying to match the frequency so that it wiggles in C as well. So it goes like this and this. I think that could help a bit. But let's look at the entire thing and see if it's an issue or not. We could also kind of slightly bring the speed up and introduce a bit of randomness. Sometimes it's good that there's not too much randomness when you do viscosity, because it can introduce instabilities, but typically I add a little bit at least, and that might take away this stair-step effect. We also might need to slow the emitter down ever so slightly, or or we might just need to, you know, bring more sub-steps or something like that. I'm giving it like 100 frames. I'm kind of liking the way it builds up. I do want like more thickness on the letter A. Kind of wish we picked another font so that it would have a bit of a hole inside. But we'll see. I think... Oh, right, we still have a keyframe on this one. Let's see. Oh, so around 150. Where is it going to be? Around 150. There. Oh, that's a little early, I think. So let's go in and move that like 50 frames ahead. We just moved it up to 185. And then it ramps down by the time we get to 200. And that should be fine. So, I want to give it a slight randomness. And I want to introduce, honestly, I think what we'll do probably is slow down the emitter a bit. So 40 maybe, and see if that reduces the stair stepping. But we can also, of course, introduce more substeps. So let's try. I'm going to be a little conservative because I don't want to change the appearance of the liquid too much either. So let's sim again. Take a look. It's better. It's not great, but it's better. Maybe I should, just so that we elaborate on this trigonometry thing, maybe let's explore this as well. Let's put in the same frequency. So the frequency is for T, and I think if I just copy that bit and I figure out, like, I want to go from, I'm looking at rotation Z here, so I'm thinking like a 25-degree sine, 25. And you can type the expression straight away in the value field if you put an equal sign first. Equals to 25 sines for t minus 1.5. So that should equate to... Now that looks pretty nice. It might lead to some liquid spilling out, but let's just see. Sometimes it's hilarious to, you know, like you're creating like this, you know, like an ice cream simulation or something, but just to see more fluid behavior, you just super crank it and like let the container overflow or whatever. Something we wouldn't do in the real world, just because it's nice to look at. So I'm straight away gonna look and see if that's helping or not. Now it's breaking up instead. Great. Yeah, we could be trial and erroring all day here. I'm just gonna try and up the speed of the emitter and give it more randomness and start again. I also might change slightly the shape, give it some more thickness. I think this is going to be better for us. Yeah. It's also kind of about time to start raising the resolution a bit. So let's not stare at this too long, because it's not going to be representative of the final result. So it might just go away on its own, this issue. So I'm going to sim again. So let's see what it looks like when we up the resolution by a factor of 10. See, it's already starting to look a lot smoother. I want to mention that if you accidentally press the F key, which a lot of us are used to from our 3D apps, you will disable the refreshing while you tumble. It's not, it's fast view is what it is in Realflow. So that might be a bit annoying, just so you are aware of that. And if you press F again, it's back. But if you do want to zoom in on something, you just go View and Zoom Selected instead. I don't think there's a shortcut. So honestly, I've just learned to stay away from pressing F over the years. It was super annoying in the beginning, but now I've kind of grown out of that habit. So let's see, we have some 50. I'm just looking at the command line, by the way, at the same time as I'm kind of like scrubbing around in the scene. So I'm like, okay, I can look up to frame 57 now. And then obviously it just snaps to the old sim since I haven't deleted it, but it's just good to know like kind of like which region I can focus my my quality checking on. I think it's starting to come close to something that we might be able to go ahead with. We have created a similar pattern to what I had in that initial sim, and something that might look decent enough to go ahead with. And I feel like we've elaborated enough on the trigonometry expressions. I want to say like I want to encourage you to use this if you're not, super keen on keyframing stuff for yourself. I really like to work this way, and I often kind of challenge myself to do more animation with less keyframes. So here's an example of that. There's not one single keyframe in this animation. I did all of the motion of the car using trigonometric expressions. So you just have to figure out how to combine frequencies on the X and Z channel to get the pattern. And then I wanted the drifting, so kind of figure out the offset for their rotation and things like that. And then obviously there's a fluid sim on top of everything, but just a really like fun challenge to do more with less keyframes, I think. And then obviously if you're kind of like a creative person or a more like hands-on creative person who likes to animate things, then you're going to think that this is heresy, what I'm suggesting now, but I think it's a lot of fun. So I hope you have found that useful, and that it might be something you could put to use in your projects. And let's I think I'm gonna let it run for a bit and we'll have a quick look. I think I might upres it to something like 50 for final. In this case, I think that's gonna be enough. It doesn't have to be, when you're doing splashy stuff, you usually go a lot higher, but here there's not going to be any splash details. All we need is a smooth, coherent mesh. So I don't think we're going to need to go any further. In the final example, the teaser that I did with the bubbles, I think it was around 50. So don't waste more time than you need to. It's looking pretty cool. I'm pretty happy about it. I like how this is scooping over the edge here. The value of 0.5 on the viscosity seems pretty cool, I think. We have a lot of detail. It's kind of resting on top of itself, but then after a while it starts to kind of like merge together down here. I kind of like the appearance of this. Yeah, I'm not going to let it run any further. I'm going to go up to... Let's see if 25 will be enough in this case. And then I will set it to cache and start tweaking the mesh once I have a few frames, and see if this is something I can be comfortable with. We're almost like halfway through the emission. I should be at, like something like million point two, I think, in poly count. Could be lower. But let's see, I got 28 frames now. We can... something I do a lot is go to show and turn off the selection highlighting, because I want to see the surface itself while still having access to the parameter. So instead of it highlighting as I have it selected, I can see it's smooth shaded. So it's actually just right click in here and go show and uncheck selection highlighting. And look at the particles instead. Some issues still to be dealt with. But for this, I'm not going to worry too much about that. I think typically I would have tried to use more forces to get it out of the way, because it's kind of like sitting in the air for a bit. I'm just like spending some time putting a bound of the mesh so that I can see a good representation but not meshing an unnecessary amount of particles. I don't want to go down too much on this, but let's see if we can go lower or higher in terms of particle radius. Let's go down a bit. I think we need to be too high. Yeah, it's good to be a bit closer to the particles, I feel. So go back and work on the filters. We already have a significant amount of smoothing going on. Let's up the steps of the relaxation of the mesh filters. There's volume filters and there's mesh filters. The mesh filters is what used to be the only thing we had to play with in order to change the appearance of the mesh after, you know, setting the polygon size and the radius. And then came the volume filters. So the volume filter is actually acting on the VDB grid, the volume grid, and the mesh filter is acting on the mesh after it being created. It's like it doesn't really matter that much to us in this case, but it can be good to be aware of. Yeah, I kind of instantly liked the way that looked. So I'm going to see, this is all swapped over to cache now. I'm going to turn off Mesh Interactive. I'm going to turn off Bounded, and I'm going to just press Sim again. And that means I now have this one running meshing. And this one, which is currently ahead, is doing Sim and meshing. So what's going to happen, as you can see, this is moving along a lot faster, because this one has to run through the sub-steps of the particle simulation. So eventually this one will catch up. So this was not, you know, the best idea in this case. But I can always like turn it off and then resume it and give it, you know, like go into the settings and give it a new frame range if there's a risk of it catching up. It might actually slow down, like the more particles gets emitted into the scene, the slower the meshing goes. But you really have to be aware of these things, because otherwise it's going to pass this one and then it's going to be meshing the original particle catches from before when we were testing the different viscosities. So I'm probably just gonna spare you from sitting around and waiting for this to sim and mesh, and I'll be back and we can start looking at creating the bubbles. The sim has gotten a bit further ahead now, and it's actually starting to look pretty cool. I really like the way it's dripping over the edge here, although I will likely not be rendering that part. But the appearance overall is a lot better than when I did the initial asim. But then again, I've taken longer time doing this. While the last few frames are cooking up, I want to start working on the bubbles. And in order to do that, I'm going to set my mesh to not compute. And I'm going to leave my original particle sim in cached mode. I'll get back to why in a bit. And now we're going to look at using graphs inside of Realflow. There are two places you can do that. You can either create a batch graph, much like you can create batch scripts. So scripts would be Python, and graphs in Realflow is kind of like a visual programming, like a node-based thing. We're going to use the simulation flow now, which you've probably seen before if you've been doing a bit of scripting inside Realflow. So the difference is not huge between this. Like if I would be creating a batch graph, I would not be running a sim or anything. I would just create a graph in here and then call for it to be evaluated. But I'm doing it as a simulation flow event so that it gets evaluated when I press sim instead. That's really the whole deal. And in the simulation flow, you can pick, like, do you want whatever you're creating, do you want it to occur before the entire sim runs? Do you want it to occur after the sim is done? Do you want it to, like, before every frame is calculated, before on every step of the sub-steps of the simulation, like pre or post, or frames post? Frames post is what we're going to do in this case. So after every frame has simulated, in our case, there will be no simulations because everything will be cached. We're just going to do like a mathematic operation and a particle fetch and save pretty much. So I'm going to select that and right click and set add graph. You see you can also add script, you can add from plugin. So this is kind of like where you really start to tweak what's going on under the hood. So I'll tell it that we want to run this graph on after each frame has been calculated. And that brings up this grid here and this interface with the graphs. So what we're going to do in here, in our case, is we're going to load the existing particles. We're going to look at the particle ID for the particles, and we're going to check if we're going to check for every nth number of particle, and we're going to filter out those particles, and the rest of them are going to be deleted. And then we're going to save those into a new particle system. So if this is new to you, then just bear with me. I don't want to go too far into depth here, so I hope that I can just take this slow and steady, and if you are a bit intimidated by it, you can just watch it over and over again, and if you need help, just feel free to reach out. So we're not going to do like cover the whole thing from A to Z on graphs. We're just going to take this slow and steady. So first thing, I'm going to hit tab, just like we can do in the relationship editor. We can hit tab and start either typing or going to a category. And we want to get a particle. So particle, get particles. And I can press on the hamburger icon up here to select it from the scene. So now we have our visco particles. And then we want to look at the ID of the particle. And the ID of the particle is a channel. So I'm going to go to particle and get channel. There we go. And I'll plug the out particles into the in particles here. And the name of the channel is going to be just typed in ID. Enter. And now we're going to take a look at the ID of the particle and examine that. So the ID of the particle, if we go to the tools and the particle tooltip and just hover here, you'll see that the ID of this particle is 298909, and the particle ID here is 537951. And the clever thing is that these values don't change ever. So that this was particle number 537951 to be born, and even if this particle dies or not, there's not going to be a new particle going to be assigned that ID, so it's unique. So if you have 100 particles, 50 of them die, and a new 100 particles are being emitted, there's a total of 250 IDs in the scene, even if that's not the existing number of particles at any point. So we need to fetch that particle ID and examine it, and we're going to do that with a math node called mod. So math mod is like, if you've done, it's really just a way to figure out if something is evenly divisible. So if I go 25 mod 5, then the result of that, or the remainder of that operation, is 0. But if I, so basically that means that 25 was evenly divisible by 5. But if I go 21 mod 6, what do you expect? Like, how many times does 18 fit entirely in 21? So we go up to 18, and then the remainder should be 3, right? So if the result is not 0, then it's not evenly divisible. In short, that might seem like a whole box of gibberish to you, but just trust me, this is a really efficient way to just filter out and check if it's evenly divisible. So what we want to do is we want to check if this channel that we're feeding into the in is evenly divisible, dividable by an arbitrary number. And a number that we can put in is just going to be an integer in this case. If you know a bit of scripting, you know there are different data types, and we want a number without a decimal point, and just going to feed an integer in here. And I'm going to feed that into the mod. So if the ID, whatever the ID of the current particle it's examining, it's going to loop over the entire array of particles. Whatever the ID of the particle it's examining is evenly divisible by the number we're putting in here. If I put 2, I'm going to get every other particle in the entire system. But if I put something higher, like, I don't know, 250, we're going to get every 250th particle. But we also need to work on the result. The result, if it is divisible by 250, it's going to be 0. So we need to now create a filter node. Filter by greater than, so condition filter by greater than. And the result, if, so we need a new integer now. Just bear with me. And this one I'm going to leave to 0. So basically, if the ID modulus whatever we put in there is bigger than 0, then it's not evenly dividable. And then we're going to delete it. And how do we do that? Well, first of all, we've got to feed this into a mask. So we take all the particles and we apply a mask to them. So I'm going to go and just type it. Sometimes I try to be, you know, as explanatory as I can, but some of these I don't even remember which category they're in. So you're just going to have to trust me. So filter by mask. So array number filter by mask is the one we want. So the array will be the particle ID numbers. So the get channel, pretty much. I'm just feeding that into the array. And the mask is going to come out of the filter by greater than node. So now the result of this node is going to be the particles that we want to delete. So now we just need to delete them. And the node for that is remove by ID. So particle remove by ID. So I'm going to feed in the particles. And I want to remove these particles. And now we pretty much just have to create the output, the save. And in order to save, we're going to create a particle save. And the particles we're going to save are going to be these. And we need to feed it not only we need to feed it not only the particles, but we also need to feed it the file path, and that file path needs to also have a changing frame number. So I need to create a path compose, and you can kind of build this up with several nodes, but you can also just browse and type in on this one. I don't want to create a huge network, so I'm going to put it in the exact same project that I'm currently working on, which is this one, and particles, and I'm just going to leave them in the root here. I'll call them bubbles, and I'll use the bin format just to be like the simplest thing. I don't know if I could probably use RPC as well, but if I don't need to, I'll just use the simplest one. And then, like I said, we need to have the current frame here. So I'll create a get current frame time, and I'll plug the frame into the frame here. And then plug this resulting file path into the particle save, and make sure you're syncing also. So I have bubbles bin, and I need to also sync, so I have those set to bin, because otherwise it's going to error out on me. And I could be creating a lot more logic in here. I could be, there are message nodes that we can set up and everything, which is going to output, in the script window in Realflow if the operation has been successful. But honestly, I'm just going to look in the folder this time. There's still things. I mean, graphs to me is, I haven't used them a ton. They're super useful, but a lot of them, there's a lot that I haven't really learned. And I would like to learn more. So if you have any good documentation on it, then feel free to pass that along. And I would be happy to make more tutorials on graphs. But currently I'm a little limited, so I just do whatever I can get by with. But there are some useful examples as well that you can use to kind of deconstruct. That's pretty much how I made this network. Finally, nothing is going to happen unless we have an evaluate node, and the evaluator is on the top there. So we just press evaluate to evaluate. And this is really it. If we have done this correctly now, our incoming particles are going to be checked if the ID number is evenly divisible by 250. They should be removed and they should be saved into the same particles folder, bubbles.bin, frame by frame, and I think we're just good to go. And the important thing, like I said before, it's important that you leave your particles a cache, because what I found out was otherwise the resulting operations was also saved into my existing cache, and you don't want that, obviously. So I'm just going to go to the first frame and simulate. And now I'm just going to go and take a look inside of my project folder. So I go open project folder, and I can see that, it's not 0-byte files. I can see that they're getting more. There's more and more of them for each frame, and that's good news. In order to check the result, what I'm going to do is I'm going to create. I'm not going to use these inside of Realflow. I'm going to use them once I get into Maya. I'm going to import them and run them. But what I can do is I can just load them up inside of the standard particles. There's a binary loader, and I'm going to set that to just cache. And I can use the bin sequence to actually load up my particles. And I'm going to turn off everything else now so I can actually see what's going on. So yeah, you can actually see maybe I canceled out too early. So you can actually see now what it looks like. And it's definitely way too many of them, and it's way too kind of even, so we need to play around with some other numbers here. So let's do that straight away. And I can leave this one in here. It's not going to write out any new particles for me or anything. It's just going to, it can write out particles for you. If you, I don't really see the point of that, like reading one sequence and writing another. Maybe if you're kind of like playing around with the particles a bit, but I don't want to do that. I just want to take a look at them. I could also be, like just creating a circle emitter and naming it the same thing, pretty much. That would also, so if I call this bubbles, that's also gonna read from the same source, really. Yeah, so let's go back to the simulation flow, which is minimized here. You can also press Control F2. And if you do that, if you accidentally close out on this, you can just double click on it here to get back. So we did every 250 particles. Let's try way higher than that. Let's try every 700. Let's try like an uneven number to see how that goes. And without further ado, I'm not going to be simming these. So they're going to be set to cache. And run the sim again. The sim is done. So let's scrub around a bit. And you can see it's definitely way less of them now, but it's still too much of a pattern. And that's inherently like the way they come out. They're of course going to be numbered, and that means that you can get patterns. But and you might want to think, then should we put some more logic into the graph so that we not only feed and look for the number 713 in this case, but also, you know, like change it every now and then or something like that. Honestly, for me, it just means that I need less particles in this very case. Of course, we could be building something like that in there, but I'm just going to try like 1017 or something. The end result of this is going to be very few bubbles. And also, once we get to a stage we're starting to feel happy with, there's also going to be additional... We're also going to take additional steps inside of Maya to, you know, mix things up with random radius and stuff like that. So it should be possible to arrive at something that we are happy with here. And now you're starting to, you know, it's not stripy anymore. So we're starting to find a number that kind of works. I still think it's way too many though. So I'm probably going to go even higher. Oops, I closed the wrong one. So I will go to 1971. And this is a result I'm starting to be more happy with. This is definitely going to work. And then inside of Maya, we're going to, like I said, we're going to give it random radius and things like that. But the cool thing here is that these particles are not only, you know, they're going to flow in the same position and in the same velocity that the original particle did, which means that it's going to look like they are advected just as the original particle system. And it's not too easy to do things like that inside of Realflow with diverso sims. In Hybrido, for example, you have a bubble system which is there for, you know, like not only should the bubble just follow the flow, it should also, you know, have a life on its own. There should be vorticity inside of the liquid, and they should rise to the surface and kind of thing. But for this scenario, you don't want that at all. You just want it to follow along. And so filtering out every X particle like this works really well in this case. So if you take a look, for example, at my teaser, you see like it's really cool that they kind of like swirl around in there and blob around. So this is exactly what we want for this look. And it really breaks things up and makes it look so much more believable. So I think this is going to be like the run I'm going to go for. So I'm just going to let this run through, and then we'll pick things up inside of Maya. And I mean, I didn't mean for this to be a Maya tutorial. It should be agnostic to whatever app you're bringing this into. But whatever steps we take in there should be applicable to anything, just like the methodology. And let's take a look. So if you don't already have it, you need to have RF Connect installed, the Realflow plugin, and it also needs to be loaded, obviously, which it should be by default. And once we have that, we can just hit the import. And first of all, let's grab a mesh. So I'll go to the meshes. Oh, obviously I have exported Alembic. So first of all, we need to stitch. And that's no biggie. So let's go to Tools and Stitch Alembic. And we're going to go to the meshes and just chunk this whole sequence in. I'm giving the same name without the frame number, obviously, and hit stitch. So if you haven't watched my crash course, this can look like nothing is happening and it has crashed, but it's going to give you, it's going to just work, and then it's going to tell you it's done. And the starting message that says stitching ... that's only going to come up when it's actually done. What we can do though is we can go to the project folder and just verify that the file is growing constantly. So I can go to the bottom. You can see that it's, 6 gigs and counting. So everything is as it should be. And it's usually a pretty stable process. I don't think I've ever had any issues with this. And there should be no problem handling this file either. So, I mean, once it's done, it's going to say done in here. But in the meantime, we can import the particles at least. So let's go the second button from the right, import particle system. So here's my bubbles. I'll just create. And we can see them playing out like so. Cool. And first thing first, before I import anything, I'm actually going to start over now. I want to make sure I'm on the same FPS as the scene, which is 30 in this case. I was lazy. Usually I'm in 24 or 25, but I was lazy and didn't change that. So I want to change that before. I don't know if it's a deal breaker, but I just, for my sanities, just to feel secure in my actions, I want to set that before I import anything. There we go. Now we have our particles there. So when I did the ABC project, I rendered everything inside of Realflow with max full preview, and that was more for sake of time, just to have saved the I/O step, but currently I only work with Redshift, so that's what I'm going to be setting up here. But this little workflow can be applied to Arnold or V-Ray easily, just with your own shaders. We have the particles. Let's go to Realflow and set stitching files, ... and done. So it is done. So we'll go back to Maya and cache Alembic, cache import Alembic. And let's see if these line up now, because sometimes there can be slightly different conventions for them. Yeah, looks good. Cool. And then obviously we're going to want the objects as well. Unfortunately, that's get exported by default. So I'm going to just press the SD, which is the scene data format. And we're going to go to the objects folder of the project and grab the animation.sd. And that's going to give us both the cube and the text. There it is. I'm probably going to set these normals too hard because they are not beveled or anything. Or we could, I could easily just be remodeling this, but I don't want to spend any time doing that. So let's do it hard way, and probably same thing for the cube. In case we are going to see something in here, maybe let's just change so that it's not cutting through the bottom. I'm going to grab the words on the lower side and just do that. There we go. And obviously for this, we're going to want, I'm not going to spend too much time right now trying to get that like honey look. It's pretty straightforward. Just you want your reflection color or refraction color to be kind of like those amber shades, but you also want to find the appropriate settings for the fog color, so that like the thicker it is, the fuller it's going to be transmitting said hue that you have in there. But I'm going to just give this a water shader for now, like a resin or something like that. I'm going to give it a higher IOR. Let's try 1.8 in this case. And a real quick lighting scenario, I guess, would be just the sun and sky. So let's create that. I don't want it to be full daylight, so I'm just going to turn this down. Let's give ourselves a IPR window. It's probably going to be messed up by the particles that are set to default right now. I don't know. Something like this could probably work in this case. And I'm going to make sure that my particles are, it works with points, but I'm just going to leave them to spheres. And I'm going to go to particle size, and I'm going to randomize. First of all, I'm going to set some kind of a ramp, and I'm going to set the radius scale input to particle ID, or randomized ID, and then you can just play with this to get kind of like the seed, and this is the overall multiplier, so the radius, and they're going to be pretty small. And then you can force some of them to be bigger by playing with the radius scale randomize. So the first thing to be aware of, which is specific to Redshift, is once you bring in your particles, the default material, of course, is not going to work, so we're going to give them a Redshift material. And I'm not going to use the same one as the liquid, and I'll tell you why. First of all, I like to, some people say that you should have exactly the same material as the liquid shader, and that's going to create the illusion of bubbles inside for you. But I personally think that they should have the same IR as air. That's going to give a nice result. But first, there's something we got to tackle. If you take a look at the bubbles themselves, they're not going to pop out too much. They're not going to be visible at all, actually. And that's because Redshift, by default, does not ray trace particles. So you need to select the particle system and object properties visibility node and make sure that that one is enabled and that it's ray tracing. And that's going to give us the particles inside of the mesh. You can see the change there. But honestly, I don't think they pop out too much if you give them the same IOR, because it doesn't give a change in refractions. It only has its own separate reflections. But if we do give them an IOR of 1 instead, that means that we're actually going from the IOR of 1, which is in the air, into the IOR that we have for the liquid, and into the IOR that we have for the bubble, which is 1, and then back into the liquid, if we're imagining kind of like a ray traveling from the source of light to the camera. So what I'm going to do is set the IOR to 1 and render again. And you'll see they pop out a lot more. They refract a lot more. And the other cool thing about this is that if we turn off the mesh, you don't see any particles at all. And that's because they have the same IOR as air. So now we're just rendering thin air pretty much. So they're only visible when the mesh is there, which means that we don't have to worry about culling them when they exit the mesh inside of, when we set up the graph inside of Realflow. And then if you're still having issues, usually you need to do a bit of lighting as well. So I'm going to put an area light in here, and I'm going to light link so that it only affects the particles by Windows relationship editors, light linking light centric, and select the area light and unselect the mesh, the cube, and the text. So now they're popping a bit more, and we obviously need to turn off the visibility and find a good intensity that works for us. But that's really all there is to it. I hope that you can get some help from this technique. I'm gonna cancel out of this render right here. I don't need to, batch render this out. We can look at the existing one for inspiration. So looking back, we've played with the basic settings for the viscosity solver in Diverso. We took a look at how to use the trig expressions on an emitter to get those kind of like repetitive motions when you squeeze out ketchup on a hot dog or chocolate sauce on an ice cream sundae, so that it kind of nicely buckles up on top of itself. We took a look at, a lot of the I/O, how to get this out, and mainly how to filter out the existing simulation into a desired every other number of particle so that we can reuse that as bubbles inside of your 3D package. I hope you found it useful, and as usual, if you like the tutorial, then feel free to let someone you know that might be interested in learning Liquid Sims about this tutorial. Feel free to share, like, and comment. I would love to have you as a subscriber so I can let you know when there's upcoming videos. Obviously not just about Realflow, but also Maya, After Effects, things like that. And if you didn't like the video, then let me know about it. Whatever I can change, I'd be happy to hear. So without further ado, I will see you in the next one, which is going to be the B breakdown, which will finally give us the time to play with Hybrido. So that's going to be fun. I will see you around, and take care.